Hello everyone, my name is Alma Chavarria and today I will teach you how to name this given alcohalide. I will be commonly referring to the IUPAC rules for alkane nomenclature as they should always be considered when deciding how to name a molecule. So let's begin. Step 1 is to find and name the longest continuous carbon chain. Now this structure is interesting because we can see here we have two paths available to us that give us the same number of carbons in our longest continuous carbon chain, which is 9. Now, to determine which path we should choose to be our parent chain, we need to skip directly to step 3 of the IUPAC rules and circle back to step 2 afterwards. Step 3 is to number the chain consecutively, starting at the end nearest a substituent group. So let's start with path A. If we chose path A, the nearest substituent group would be bonded to carbon 3, and it would be this whole isopropyl substituent. If you're wondering what would happen if we started numbering from this side and why I didn't do that, I didn't do that because then our nearest substituent would be this fluorine substituent, which would be bonded to carbon 4 of the longest continuous carbon chain, which is of course higher than carbon 3. So path A's best chance is to be numbered this way and have the nearest substituent on carbon 3. So I will write that here so we don't forget, 3. Now let's look at path B. If you number it the way I have here, our nearest substituent that would be bonded to carbon 2 of the longest continuous carbon chain, and it would be this methyl substituent. If you wanted to try to number starting from this end instead, I didn't do so because we have the same case as in path A where the nearest substituent would be this fluorine atom, and it would be bonded to carbon 4 of the longest continuous parent chain. So the best case for path B would be to be numbered as written in red. And if you do so, the nearest substituent would actually be on carbon 2. So of course 2 beats 3, so we will indeed choose path B to be our parent chain. So let's move on. Now that we've decided which path to take and how exactly to number the molecule, we can circle back to step 2. Step 2 is to identify and name the groups attached to this chain. Now, I always like to write my components of nomenclature as soon as I determine them. So I'm going to do that first with the parent chain name. The parent chain name will go at the end of our molecule name, and it will be directly related to the number of carbons within the parent chain name. In this case, it's 9. If it is 9, the parent chain name will be nonane. So I always like to write that down. Now let's look at our substituents. Substituents are any group not included within the longest continuous carbon chain, but directly bonded to at least one carbon within the chain. So that would be this group here, this group, and this group. Let's identify what exactly these substituents are called. So this substituent is a 1 carbon substituent. It's called a methyl group. This substituent involves 2 carbons, and that is called an ethyl group. This F represents carbon 6 being bonded directly to a fluorine atom. In nomenclature, we write this as fluoro. Great. So now that we've done that, we need to identify the locants. The locant is the carbon number that is directly bonded to the substituent. So let's look at methyl. Methyl was directly bonded to carbon 2. So we would write 2 and separate it by 1 dash with no spaces before the methyl. With the ethyl group, it is directly bonded to carbon 3 of the longest continuous carbon chain. So we'd write 3 in the same way. And for the fluorine substituent, it is directly bonded to carbon 6 of the longest continuous carbon chain. So we would write 6-fluoro. Great. So now that we've done that, let's move to step 4. Step 4 is to designate the location of each substituent group by an appropriate number and name. So we have already actually done that using my method of jotting everything down as soon as you determine it. So that's already done. That is listed here. That is listed here. So now we have the components of our nomenclature and we're ready to put it all together. There's only one step left, and I want to make it very clear what the components of nomenclature are. they will be our substituents highlighted in red and our parent chain suffix that goes at the end of our name. The substituents highlighted in purple and the parent chain name highlighted in red. So let's move on to step 5. Step 5 is to assemble the name, listing groups in alphabetical order using the full name. So I want to make something very clear that in this case, we are specifically alphabetizing the first letter of each substituent. The parent chain name will always go at the end of the nomenclature, so we don't need to worry about alphabetizing the N in nom name because it's always going to go at the end. So let's just worry about the M, E, and F in our substituents. Also, a quick side note, I do want to say, if you ever run into a case where you have two of the same letters that you're comparing for alphabetical order with your substituents, you would then move into the word to the second letter with both substituents and then compare those and so on. But in this case, we don't have to worry about that because we have 3 distinct letters, M, E, and F. So the order would, of course, be E comes first, then F, and then M. That would be the alphabetical order. So now that we've done that, we just have to put everything together. So it would be 3 ethyl, and then the next substituent would come after 1 dash. So the next substituent is 6 fluoro, separated by a dash. Next substituent is 2 methyl. And then our parent chain name, suffix, as I said, will just be plopped in at the end with no dashes or spaces, just like that. So that gives us a finished nomenclature, determined to be 3 ethyl, 6 fluoro, 2 methyl nonane. That's all for today. Thank you so much for your time and attention. If you have any questions, please let me know. And I look forward to teaching you something else in the future.